In this video, we will solve a question from JEST 2024, which is from the topic hydrogen atom. We are asked to evaluate the value of 8 by 3 expectation value of R divided by most probable value of R in the ground state of hydrogen atom. And we are given the radial part of ground state wave function of hydrogen atom, but this is error. This is not radial part, this is total wave function. This is psi 100 because R10 is equal to 2 by A0 raised to 3 by 2 e raised to minus R by A0. The radial part of wave function is actually this, and angular part is y00. This is equal to 1 by root of 4 pi. When you multiply angular part by radial part, then you will get the total wave function. So total wave function is psi is equal to psi 100 is equal to 1 by root of pi A0 cube e raised to minus R by A0. Expectation value of R is defined as, with respect to 100 state, this is equal to psi 100 star R psi 100 d tau. D tau is the volume element. D tau is equal to R square sin theta dr d theta d phi. Therefore, expectation value of R with respect to ground state of hydrogen atom, this is equal to psi NLM star times psi is modulus of psi 100 squared times R, and we have 4 pi R square dr. This is the volume element. When you integrate sin theta d theta d phi, theta limit is from 0 to pi and d phi limit is from 0 to 2 pi. So when you integrate this, you will get 4 pi, and R ranges from 0 to infinity. So this 4 pi is written here. So expectation value of R is equal to integral 0 to infinity modulus of psi square is 1 by pi A0 cube e raised to minus 2 R by A0, and then we have R cube dr and a 4 pi which is outside. This is equal to 4 times pi gets cancelled divided by A0 cube integral 0 to infinity e raised to minus 2 R by A0 R cube dr. Now there is a standard integral 0 to infinity x raised to n e raised to minus ax dx. This is equal to n factorial divided by a raised to n plus 1. Here we have n is equal to 3, n is 3, and a is equal to, in the place of a we have 2 by A0, 2 divided by A0. Therefore the value of this integral, this is equal to 3 factorial divided by 2 by A0 the whole raised to 3 plus 1, which is 4. 2 by A0 the whole raised to 4. Therefore we have expectation value of R is equal to, in the state 100, this is equal to 4 by A0 cube times 3 factorial divided by 2 by A0 the whole raised to 4, which is equal to 4 times 3 factorial is 6 divided by A0 cube times 2 raised to 4 is 16 divided by A0 raised to 4. This is equal to 24 by 16 times 1 by A naught, which is equal to 3 by 2 A naught. This is the expectation value of radial coordinate in the ground state of hydrogen. To calculate the expectation value of R in the state NLM, we have an already developed formula, which is A naught divided by 2Z times 3n square minus L into L plus 1. If you use this, you will get the answer very directly in a minute. Z is 1 for hydrogen atom and n is given to be 1, so 3 into 1 square minus L is 0, 0 into 0 plus 1. Using this formula also you can calculate the expectation value of R in the NLM state. If it was this much easier to find the value of expectation value of R, then why did we do all this integration? The answer is, if question is modified to calculate expectation value of R square, then you do not have a ready-made formula in that case. Then you will have to do the integration. So you need to know how integration is done. To calculate the expectation value, how integration is done, you should know that. Because sometimes you are asked to calculate 1 by R expectation value, and for each of the expectation values you cannot study the formulas, right? That is not practical. Coming back to the question, we now calculated the expectation value of R. We calculated this. Now we need the most probable value of R. To get the most probable value, we differentiate with respect to R d by dr of R square times modulus of RNL square, and then set it equal to 0, then solve for R, and the value we get, it is the most probable value of R. Therefore this implies d by dr of R square times R10 modulus square is, we know that R10 is 2 by A naught cube, A naught raised to 3 by 2, here raised to minus R by A naught. This implies R10 modulus squared is 4 by A naught cube times e raised to minus 2R by A naught. This is equal to 0. Now constants does not matter. This implies d by dr of R square e raised to minus 2R by A naught equal to 0. Now you apply the product rule for differentiation. You will get two R times e raised to minus 2R by A naught plus R square times e raised to minus 2R by A naught times minus 2 by A naught. This is equal to 0. Now if you divide the whole equation by 2 e raised to minus 2R by A naught, then you will get R plus R square minus 1 by A naught is equal to 0, which implies R times 1 minus R by A naught is equal to 0. R equal to 0 or R equal to A naught. This is not acceptable. Therefore R most probable is equal to A naught. Again we have the formula for most probable value. If L is equal to 0, R most probable is given by n square A naught by Z. Here n is equal to 1 and Z is equal to 1. Therefore we have R is equal to A naught. So this formula is applicable when L is equal to 0. R most probable is equal to n square A naught by Z. Now let us put the values. We have to calculate 8 by 3 expectation value of R divided by most probable value of R. So this is 8 by 3. Expectation value of R is 3 by 2 A naught divided by most probable value of R is A naught. A naught gets cancelled. So this is equal to 24 divided by 6, which is equal to 4. So the correct answer here is 4. 8 by 3 times expectation value of R divided by most probable value of R is equal to 4 in the ground state of hydrogen atom.